embedded mindset. In this video, we are starting our journey into STM32 microcontroller programming. Instead of using pre-built libraries, we are going with the bare metal and directly programming the register. Today's let's take a simple example of blinking an LED in STM32 using a GPIO at the register level. As of now, I am having the Nucleo-L452RE-P board. This is how the boards look like. And in this board, this contains the STM32L452 series IC, and this is the block diagram of that IC. Here you can see there are GPIO ports like port A, port B, port C, port D, and port D, and also the port H. This all ports initially A, B, C, D, E has a 16 GPIO pins each, but the GPIO port has only the 3 physical interfaces which are used for the different peripherals. Today's our goal will be make any one of the pin in GPIO port A, declare it as an output and blink the LED. So let's begin in the program. Let's create the file first. Now I need to select the board configuration. Like Nucleo-L452RE-P. This is the board which I am using. Here you can see, while entering the part number, you will find the board here. You need to select this, and if you need any of the description to be read, you find everything here. In the features, documents, and resources, you can download the data sheets are available here. And after selecting here, you can go with next. Now let's select the file name. I will give it a simple name as project 1 LED blinking. I'm going to do the C programming, and I'm using the default location which has been set and an executable file, and the target project type will be STM32. It will ask initial all the peripherals with their defaults mode and yes. You will find this page now. Here you can see in this board what all the initialization of the board has been done before. Like the blue B1 push button has been initialized to PC13, and RCC oscillator 32 has been declared for PC14. Like that. For the PA2, the USAR transmission. For PA3, the USAR RX pin. And for PE B13, the LED green light has been declared and they have been initialized in the board itself. But if you want to use the built-in function at that time, declare these pins. Like if I want to make the PA0 as an output pin, we will select here as a GPIO output and declare this as a GPIO output pin. But we are going to not declare here. We are going to use the built-in function, not using the built-in function, but the bare metal function, so that I will declare the pin initialization in the program itself. Here you can see the pin configuration has been already initialized here. But as I'm not going to use all this, just going to declare the PA1 pin as an output. I will connect an external LED here and show the LED blinking concept. For this all initialization is not required for me. Now the program goes like, initially I will add the header as hash include STM32 L452RE-P. This initialization is for all the STM32L4 series microcontroller. It contains all the registers definitions you needed to control the chip peripherals. Now I have told it that I'm going to initialize this PA1 as an output. For that, I need to enable this for an clock. Here in the reset and clock control, you will find the topic called AHB2 peripherals clocks enable register. Here you can see there is a GPIOA enable pin which we need to enable. To enable that pin, we need to set that bit to 1. Means this bit need to be set to 1 now. How we are going to do that is by this register value. I'm going to initialize static mode config like we need to point towards this register and I need to OR option with this. I will make a one side unsigned bit to merge towards left side with no shifts, so that this 1 will indicate towards here and this will make this enable pin. Otherwise you can also do it like you can point it towards or with RCC AHB2 enable pin, this one, but we need to point the name now, that is GPIOA enable. This is what the name for GPIOEN. Here you can see GPIOAEN. These both are same. You can use any one of them. going to use the bitwise operation. Next, the other thing which you need to initialize is the mode register pin. It means the pin which it needs to work as an input pin or an output pin. For that, open the same datasheet and refer to the GPIO mode set pin. Here you can see general purpose input output. In this, you will find a GPIO registers. Here you can see a GPIO port register. It's defined as GPIOX for A to H. These all are the reset value for the ports. We have 5 ports, each of a 16 pin here. Now, these 2 bits register to 1 pin of the port like. Suppose I am taking a port A. This represents to me as PA0, PA1, same till PA15. These are the 16 pins. Now I'm going to make this PA1 as a output pin. For that, what I need to initialize is, you can see here, a 0-1 general purpose output. It means I need to make here as 0 and 1 to this bit. For that, I'm going to initialize with GPIOA underscore modder. Here you should not use the underscore because we need to point towards now the register pin. So modder. First I cannot initialize it directly with 0 1. First I will clear this bit because there are other alternatives also. If the pin was initially 1 0, if I initialize directly with 0 1, there might be a condition that this pin will be 1 1. So it's better first to clear it. First I will make it as a 0 0. So for that, and I will first I have cleared the bit. Now I will make this bit as 0 1. So let's do for it. To make the first 2 bit as 0, I will do a AND operation with, I will move 3 unsigned towards left by 2, means 1 1 will be moved towards left by 2 bits. It means here it will be a 1 and 1. Now let's make what of this, which will become 0 0, and make this both the bits to a clear, and then I want to make it in a 0 1. So GPIOA modder or with 1 2. Now what this do is, I will make 1 to move towards the left by 2 bits. Like 1 will move from here to here, from 10 to here. It becomes 0 1. So by this we can make the port A1 as an output pin. This is the only configuration which you need to do. Now, coming to the main program, I will call the configuration function first. Then I will run this LED blinking for an infinite time. Now let's declare a pin position. That is define LED1, which indicates towards GPIO A R. I will tell you now what is this GPIOA ODR. We need to point towards GPIOA ODR. In the same datasheet, we'll find the GPIOA port output data register as GPIOX ODR. Now, by making here this register bit 2 high or a low, you can make the pin to work. Now, this represents like this one is PA0 for us, and this one will be PA1. Same, the 15 represents the each pin. Now we need to deal with the second bit. For that, what I'm going to do is I have made the GPIO ODR pin as an LED1 now. Now LED1 I will make XOR with I need to toggle just a 1 bit unsigned towards 1. Why going towards 1 means the 1 which is here, it will be moved towards the left by 1 bit, so that the operation will be done in this bit which we have declared as an output for us now. By doing an XOR, this will make the LED to toggle. That's make the pin, if it is low it becomes high, and if it is high it becomes low by the XOR operation. So this is an declaration. We need some delay now so that the output can be viewed easily. For that I'm going to use a blocking delay like dial int to 0 should be less than some random delay. This works for a blocking delay, but keep in mind that we are not going to use any of the specified time now. It's just a blocking delay. The specification of a time we will learn in the upcoming videos. This is a simple code. Now let's build and debug this, and let's see the output. I have connected my STM32 to my PC. Now let's run the code. Okay, there are a small mistake that this is GPIOA and forgot to add I here. save, build, done. Yeah, the code. Yeah, the code has been uploaded. You can see the LED blinking. At the end of the video, you will find the small demo, and this is the simple code. And if you like the video, please like, subscribe to my channel. Thank you.